In this video, we're going to look at finding a critical value for a confidence interval. There are some common critical values because we tend to use common confidence intervals. I'm going to let you do the 80% row on your own because it's part of one of your homework questions. We're going to look at the 90% confidence interval, 95% confidence interval, and 99% confidence interval, which are your most common confidence levels. So each confidence level has a corresponding value of alpha. Alpha is called a type 1 error. And I'm going to let 80 for you to do. But if we are 90% confident, that means we have 10% that we're not confident. So we would say that the alpha level is 10%. We're actually going to always use alpha as a decimal, so I would move my decimal point 2 places, and my alpha level would be 0.1. So if I'm 95% confident, that means there's 5% of me that's not confident. And so my alpha level, the error rate, the type 1 error, is 5%. And again, we'll write that as a decimal, 0.05. And finally, if I'm 99% confident, that means there's 1% of me that's not confident, and so I would have an alpha level of 0.01. Now, our confidence levels really correspond to the normal curve. So we'll look at this 90% one first. My confidence level is 90%. That means from the mean, which we're using as a z-score, I would have 90% confidence right here in the middle. We talked about that our error rate is 10%, and that error is divided between the two tails. So 10% divided by 2, the error rate down here, 5%, and the error rate up here, 5%. So in the next column in my chart, the alpha divided by 2, which is the area in the tails, is half of the alpha value. So we just take 10% divided in 2, and it's 0.05. Now we want to find the z-score, or the critical value for that 5%. So we're going to use our normal table of values, but let's take a moment to think about what we're looking for. The area here in pink is 0.05. That area will have a negative z-score. The area up here in pink is also 0.05. But when we look on our z-score table, it always gives left values. So if this is 5%, the area that is left of this boundary is 95%, 0.95 as the area. So next we'll look at our z-score table. We're looking for areas. The two different ones are 0.05 and 0.95. So here is my z-score chart, and I'm looking for an area, and I'm looking for that area to be 5%. So it looks like that would be right here where this little star is. Right between here is 5.05 and 4.95. And that little star goes down to the bottom of my z-score table. And so it says down here that the area of 5% has the z-score negative 1.645. So I want to also look for an area of 0.95. So let me go to the next page of the table. And so I'm looking in my z-score chart. And again, I get this little asterisk. Right between these two values would be exactly 0.95. And again, that's taken down to the bottom of my z-score chart. And I see it is the z-score 1.645. So coming back to my drawing, this z-score was negative 1.645, and this z-score was positive 1.645. And that makes perfect sense because we know that the normal curve is symmetric, so finding the same z-score makes sense. This z-score is also called the critical value, and that is the score that divides between what's above and what's below. And we're going to write the positive one in our chart, because when we use this to calculate the error, the formula has the plus or minus in it, so that'll give us the positive as well as the negative. So let's try another example, and we'll complete the next row of the chart. So in our next row, our error is 5%. So the area in the tail will be half of 5%, or 0.025. When I take that to my picture, and that means the area on the left-hand side, 0.025, and the area on the right-hand side, 0.025. In this picture, we're working at a 95% confidence level. So again, I want to go to my normal curve. But before I do that, I need to figure out what is the total area to the left of this upper boundary. So I would be taking 100% all of the data under the curve and subtracting out 0.025, and that should give me 0.975. So I'm looking for this value in my z-score chart. So here I am in my z-score chart, and I'm looking for an area of 0.025. So here's too many zeros. Gonna go down a little bit. And it looks like it's exactly right here. And so when I look at what value that is negative 1.9. I have to go up. 1.96 up here. And then I want to look at the positive one too. So again, I'm going to flip pages here, and I'm looking for an area of 0.97975, exactly right there. 1.9, and we would expect it is 6 again, so going up through there. Yes, it is. So I come back to my picture, and we found that this is positive 1.96. This is negative 1.96. We see that symmetry again. And so our z-score, or critical value, and we're going to use the positive one, knowing that the formula that we will use this in has the plus or minus to get both of them. So finally, we're going to repeat the process for 99% confidence. So this time our confidence level is 99%. That meant our alpha level was 1%. So splitting that between the two tails, each tail would have an area of 0.005, half of 1. So that's this area over here, as well as the area to the right-hand side. If we subtract from 100, we're looking for an area that would be 0.995. So we're going to go to our z-score table, and I'm on the positive ones right now, and I'm looking for an area of 0.995. So I know I have to scroll down here a bit, and I see this little star here, 0.9949, 0.9951. It's right in the middle, and as we saw before, that's going to have an answer at the bottom, and so we get 2.575. We've seen the symmetry, so we know full well if we go to the previous page and look at the negative ones, we're going to find the exact same thing. Here I see the asterisks right up here. Our score that we're looking for is right there between those two. I go to the bottom, and it shows this negative 2.575. So back at my picture, we found z-score of negative 2.575. and positive 2.575, and so we'll use a critical value of 2.575. These are the most common ones, and as I mentioned before, the 80% one will be in your homework, and you can go through the same process to figure out the corresponding value of alpha, the tail area, and the critical value.